This week we're going to read a text file and parse it into geographic polygons. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to take a look at how to read the AIRMETS and SIGMETS file that we can get from the Aviation Weather Center. And it's a little bit unique because we're going to get a text file, a CSV, that contains geographic polygons. Now, we've looked at how to plot geographic polygons before because we've read in shapefiles from the Storm Prediction Center in previous MetPy Mondays. But this week we're going to start seeing how to make our own. And this is not going to be a straightforward process, as you'll see. All right, so coming over into a notebook, for now, we'll just say that we have this file. We'll look at how we can get this file programmatically later, of course. But we see that there's some header information, no errors, no warnings, how long it took for this request to be returned, the data source, how many results there are, and then finally we get to our header row. So we know that we're going to need to skip some rows to start with. In fact, we're going to need to skip 5 rows to get to the header. So first, let's just do our imports and read this file in and see what's there. It's a little hard to see in plain text. So we're going to import GeoPandas because we know we're going to be dealing with geographic objects, though we're not going to get quite that far this week. We're going to import pandas as PD, matplotlib.pyplot as PLT, and then from shapely.geometry, I'm going to import the polygon geometry, import cartopy.crs as ccrs, import cartopy.feature as cfeature. Okay, so let's take a look at our file just by loading it in to a data frame. We're going to use the read CSV function. I'm going to pass our file name airsig.txt. And the only parameter that we should need to pass is skip rows. We know we need to skip 5 rows. And if we look at that data frame, there we go. But we're most interested in right now is this lat-lon points. So if we look, in fact, we could look at a specific, we could say pick the 4th thing. So we're getting that with iloc. Then we look at the lon lat points data series. This is the text string that we have to work with to create this lat-long box. So what I'm going to do is make a function, make polygon from points text, and it's going to take some text. So what we need to do in this function is actually we're going to make lat-lon from points text. I'm going to split this into 2 functions just for a little bit of clarity. Takes text string from AWC and returns lat-lon lists. Okay, so looking at that string, we see that it's semicolon delimited with a colon separator for the X and Y fields. So we know that we're going to need to do some split operations. So the points, the individual points in this box, we can split that string on the semicolon. I'm going to create a couple of empty lists to hold our lons and lats. I'm going to say for pair in points for each item in that points. The lon and the lat, we can split each item based on the colon. So we're going to append to lons the lon, except it's going to be a string, so we're going to need to float to cast that to a float. Lats.append float lat. Then we're going to return lats and lons. So why did I decide to make this its own function? One, it is a single action. It's very easily describable what it does. We don't have to say it takes an entire text file, it opens it up, it parses it, and so on. Also, other products from the Aviation Weather Center may very well use this exact format. So if we have that in a function, now it's no longer tied to AIRMETS and SIGMETS, but it could be tied to anything. We'd have to call this function once we get to this simple text string. So that's why I chose on the fly to make this a separate function. So now we're going to say make polygon for text. Again, if these were going in the MetPy library, I'd probably name these somewhat differently, but we're prototyping here. Okay, and so this function is going to take AWC, AIRMET, SIGMET text, and create polygons. Okay, so we're going to pass it the text, or we could actually pass it a file name. So let's, again, rename. This is part of the prototyping process. Make polygons for AIRMET SIGMET. The first thing that we need to do is read in our data, which we already know how to do. We're going to copy that and paste it, replace our file with fname. Now we've got our data frame. I'm going to create a polygons empty list. Then for row in dataframe.iterRows, row, remember this returns a tuple with the index of the row and what's in the row. So row is going to be equal to row 1 because we want what's in the row, the content. We don't really care about the index here. Now, what is the text for that specific polygon? It's contained in the lon lat points data series. So we're going to call make lat lon points from text with that row's lon lat points data series. And what's that going to return to us? That's going to return to us lats and lons. For each of those lats and lons, we're ready to make a polygon. So our polygon, P, is equal to an instance of the polygon object, which is going to be zip, lons and lats. So that's going to go through both of those in lockstep to create lon-lat pairs. And finally, polygons.append P. So that should create our list of polygons. We can return polygons. So let's try it out and see what we get. Make polygons for AIRMET SIGMET. Our file name was airsig.txt. And we get a bunch of polygons back. So let's save those to a variable called polygons. And let's make a quick map. So our coordinate reference system for the map is going to be our favorite Lambert conformal with a central longitude of -100, a central latitude of 45. Our bounds for this going to be -122, -75, 25, and 50 for our latitude and longitude bounds. I'm going to create an instance of figure. We're going to add a subplot to this figure. It's a little bit different than how we normally do it, but I do like to show different ways because you'll have to read code written by different people who have different preferences on how to do things. We're going to set our extent, unpack bounds into there, and we should tell it that those bounds are in Plat Curie or just latitude, longitude. We can add a feature. Let's do the coastline. And we'll say with scale of 1 to 50 million. We'll put the states on with a line width of 1/2, so it's a little bit thinner line. Let's run that, make sure that it's our map CRS. Get a map that looks like what we were expecting, and we do. So now we can go over our polygons and add geometries. We want to add each geometry. These are in Plat Curie because they're latitude, longitudes. The face color is going to be the string none. Edge color is going to be tab brown. And line width, we're going to make it 3 so it's nice and bold. There we can see we've got quite a mess here. Even if we cleaned this up and only looked at, say, convective SIGMETs, there's still some very strange things going on with the drawing. For example, if you look at these boxes down here or over here. So what do we need to do to get these to plot correctly? That's something we'll look at on next week's MetPy Monday.